Hi, my name is Johnny Hancock from Agilent Technologies. In this short video, I'd like to show you some side-by-side measurements of typical automotive application measurements using Agilent's 4000 X-Series oscilloscope versus the LeCroy Waverunner oscilloscope. Automotive systems operate in a naturally harsh environment. Lots of transients due to noise, ignition interference, other types of transients. Here we show an example of an infrequent transient captured on an Agilent oscilloscope. This particular transient only happens 1 out of 40,000 occurrences of this particular waveform. Typically, this digital pulse has a normal rising edge, but sometimes it has what we call a non-monotonic edge. Most scopes cannot capture this due to insufficient waveform update rate. But the Agilent scope can update up to 1 million waveforms per second, so it easily captures this infrequent anomaly. Now, the next thing an automotive engineer would want to do in order to analyze this particular transient is to isolate it. That is very easy to do on the Agilent 4000 X-Series oscilloscope. You simply draw a box in the area of the anomaly, and then the scope isolates the transient. On the LeCroy scope, here we show the same exact signal, but you don't see the transient. At this setting, I have minimized the memory depth. I've optimized in order to get the fastest waveform update rate utilizing real-time sampling. But at this time-based range, the maximum waveform update rate is just 100 waveforms per second, and of course, you don't see the transient. Now, if you did see a transient, if it was occurring often enough, what would you do to trigger on that? It's very difficult. The LeCroy scope could trigger on this transient, but it would mean setting up a very complex trigger condition that most people don't understand. The Agilent scope, as I showed, just simply draw a box and the scope automatically triggers in that particular zone. Here we show a more typical automotive application of triggering and decoding a CAN packet of data, typically called a CAN frame. So this particular frame of data, we're triggering on frame ID 07F. Now, one thing you can see here is an extremely fast decode update rate. That's because Agilent scopes utilize hardware-based decoding, which gives you a virtual real-time update of the decoding. Now, the benefit of that is if you can see the red flashing here, as well as up here, the scope is capturing error frames on this particular frame of data coming from the CAN bus. The real-time update rate of the decode shows you infrequent error conditions, just like fast waveform update rate shows infrequent transients. Now, another unique capability of the Agilent scope is a real-time frame counter. Here we show the total number of frames captured, overload frames, error frames, and bus load. This is a real-time counter. Even if I stop acquisitions, the frame counter continues to run. Let's begin it again. Now, the bus load measurement is a very important measurement for automotive CAN applications. Here we see we are measuring approximately 24% bus load. Typically, automotive engineers don't want their CAN to be operating any higher than 30% bus load in order to minimize arbitration and to minimize errors. So this is a real-time frame counter and bus load measurement. Let's take a look at the same measurements on the LeCroy scope. Here we show the same CAN frame on the LeCroy scope. The decode update rate is much slower. The number of times it captures the error frame is now much more infrequent because of the slower update rate. The LeCroy scope utilizes software-based decoding, which is more software intensive and much slower. You see a slower waveform update rate and a much slower decode update rate. However, one thing that many people like about the LeCroy scope is the format that it overlays the decode information and separates the fields. Now let's take a look at the bus load measurement that we saw on the Agilent scope. On the LeCroy scope, at this setting, it's measuring 45%, which doesn't agree with what we measured on the Agilent scope, which remember was about 24%. Now if I change the time-based setting, now it's measuring about 9%. Now it's measuring about 24%. The reason for the difference in measurements is because the LeCroy scope uses software measurement techniques to measure bus load. So it's measuring the frame time relative to the acquisition time. It is not a real-time measurement like the Agilent scope. If I compress more frames on screen, it makes a more accurate measurement. This is an example of a dual bus measurement. In this case, we're capturing a FlexRay bus and a CAN bus. Down here is the time-correlated decode trace of the FlexRay bus and the decode trace of the CAN bus. Now what's unique about the Agilent scope is what we call the Lister display. Some scopes call it an event table. It can time interleave data captured from the FlexRay and the CAN bus all in one table. Now automotive systems typically have multiple serial buses, and data is often passed from one bus to the other. With the time interleaved Lister display, we can see FlexRay frames in blue, CAN frames in the light green, and then here more FlexRay frames. We know exactly when data is passed from one bus to the next. Let's now take a look at this on the LeCroy scope. Here we show the CAN frame, here we show FlexRay frames. However, it does not have a time interleaved Lister or table. They can display two tables simultaneously. This is the table for the FlexRay frames. This is the table for the CAN frames. But if you want to know the time from one frame to another frame between the two different buses, you're going to have to correlate manually the timestamp on each of the frames in the two different tables. We're now showing an example on the Agilent oscilloscope of CAN symbolic level decoding. Now, no longer is the bus being decoded in simple hex characters, but now we're displaying in more human terms. In this case, the frame ID has been translated into engine data, which is called a message. And here we also have what is known as signals. Here we're showing fuel, temperature, speed, all of this being converted from hex into symbolic code. Now the way that happens on the Agilent scope, you can very quickly import a industry standard .dbc file that defines a particular CAN network for a particular automobile. And then once that's imported, the scope automatically parses and saves that data. And then in the serial menu, now you can select to see the information in either symbolic or hexadecimal. Now the LeCroy oscilloscope, I don't have the option to show it, but the LeCroy oscilloscope can do the exact same thing. However, the big difference between the Agilent solution and the LeCroy solution is how much you have to pay for that particular option. The CAN symbolic capability in the Agilent oscilloscope comes standard with the DSO X4 Auto option, which is a licensed option, and it's priced approximately $1,500. On the LeCroy oscilloscope, it's part of the VBA option, and it's only available on the Waverunner 6ZI and higher, and that particular option is priced at nearly $5,000. For our last measurement, we're going to show a CAN eye diagram mass test. This is the only oscilloscope in the industry that can perform this particular measurement. It is an overlay of every bit of every frame. What you see here from this point to this point is 1 bit time. Now this is 500 kilobit per second, so that's 2 microseconds of time. It shows you the various amplitude of pulses, which is a result of nodes being separated by distance and different terminations. You can have different amplitudes. Plus, every time there's an acknowledgement pulse, it gets pulled to a much lower level when all nodes pull on the bus simultaneously. And also during arbitration, the same thing happens. Now also what you see here is what appears to be significant jitter, but it's not actually jitter. It is actually showing you the propagation delay in a CAN network from one node to the next node and then back again. So that's 2 times the propagation delay of the length of the CAN network. The LeCroy oscilloscope does not have this measurement. This is unique to only the Agilent scope. As you've seen in this video today, Agilent's oscilloscope has many advantages when it comes to making measurements on automotive systems. If you'd like more information, visit the URL listed on the screen or call your local Agilent distributor. Thank you.